Hey friends, welcome to the YouTube channel all about electronics. So in the previous video, we understood that what is vectors, and then after we understood that how the vector addition and the subtraction can be done, and then after we also understood the concept of the vector fields. So in this video, let us see some solved problems based on the concepts that we learned in the previous video. So here, the first example is based on the vectors. So here in the first example, we have been given the 3 points, that is M, N and the P in the Cartesian coordinate. So here, first we have been asked to find the addition of the vector Rmn plus Rmp. So in the Cartesian coordinate system, let's say there is some point M and there is some point N. So from the origin, if we draw a vector towards the point M, then that will be a position vector Rm. Similarly, if we draw a vector from the origin towards the point N, then that will be a position vector Rn. So here, if we see this vector Rmn, then that is basically a position vector. That is the vector that is drawn from the point M towards the point N. And mathematically, it can be represented as this vector Rmn that is equal to this Rn minus Rm. And in the previous video, we already understood that how to represent this displacement vector, right? So here, this vector Rn can be represented as this 3ax minus 3ay plus 0az. And similarly, this vector Rm can be given as minus ax plus 2ay plus az. So now this vector Rmn is equal to this Rn minus Rm. So here we will do this subtraction component wise. So we can say that this Rn minus Rm is equal to 3 minus 1 times ax plus minus 3 minus 2 times ay plus 0 minus 1 times az. That means here this vector Rmn is equal to this 4ax minus 5ay minus az. So in this way we got this vector Rmn. So similarly, let us find this vector Rmp. So for that we also need the position vector Rp. So here this position vector Rp can be given as minus 2ax minus 3ay minus 4az. And here this vector Rmp can be given as this vector Rp minus Rm. And once again that can be found by doing the subtraction of this vector Rp and the Rm component wise. So we can say that is equal to minus 2 minus 1 times ax plus minus 3 minus 2 times ay plus minus 4 minus 1 times az. So that is equal to minus ax minus 5ay minus 5az. So in this way we got this vector Rmp. And here as you can see, we have been asked to find the addition of this vector Rmp and the Rmn. That means here this Rmp plus Rmn is equal to the addition of these two vectors. So once again we can find that by doing the component wise addition. That means here for these two vectors we will add their x, y and the z components respectively. That means here this Rmp plus Rmn is equal to this 4 minus 1 times ax plus minus 5 times ay plus minus 1 minus 5 times az. So that is equal to 3ax minus 10ay minus 6az. So in this way we got the addition of these two distance vector. So apart from that, Here we have been also asked to find the magnitude of this 2rp minus 3rn. So let us find that. So here we know that this rp is equal to minus 2ax minus 3ay minus 4az. And similarly, we know that these Rn can be given as these 3ax minus 3ay. That means here these 2rp minus 3rn is equal to these 2 times minus 2ax minus 3ay minus 4az minus 3 times these 3ax minus 3ay. So here, let us add the x, y and the z components separately. That means here, if we further simplify it, then we will get minus 4 minus 9 times ax plus minus 6 plus 9 times ay plus minus 8 times az. So that is equal to minus 13 times ax plus 3ay minus 8az. So in this way, we got this vector 2rp minus 3rn. So now, we need to find the magnitude of this vector. So in general, we know that the magnitude of any vector A can be given as the square root of the ax square plus ay square plus az square, where the ax, ay and the az are the x, y and the z component of the given vector. So in this case, the magnitude of this 2rp minus 3rn is equal to the square root of minus 13 whole square plus 3 whole square plus minus 8 whole square. So that is equal to square root of 169 plus 9 plus 64. And if we further simplify it, then that will come out as 15.556. So in this way, we got the magnitude of this vector 2rp minus 3rn, where both rp and the rn are the position vectors. So similarly, now let us see the next example. So in this example, we have been given that this vector A extends from the origin to the point 1, 2, 3. And similarly, the another vector B extends from the origin to this point, that is 2, 3, minus 2. So here, first we have been asked to find the unit vector in the direction of A minus B. And then after, we have been asked to find the unit vector in the direction of the line that is extending from the origin to the midpoint of the line that is joining the points A and the B. So first of all, let us see the first part and let us find the unit vector in the direction of A minus B. So here, as per the given data, we can say that this vector A is equal to ax plus 2ay plus 3az. And similarly, this vector B is equal to 2ax plus 3ay minus 2az, because both this vector A and B are starting from the origin and they are directed toward these 2 points. That means here, these are the representation of the vector A and the B. So here, to find the unit vector in the direction of the A minus B, first we need to find this vector A minus B. So it can be found by doing the subtraction of these two vectors component wise. That means this A minus B is equal to 1 minus 2 times AX plus 2 minus 3 times AY plus 3 minus 2 times AZ. So that is equal to minus AX minus AY plus 5AZ. So in this way, we got this vector A minus B. So now in general, we know that the unit vector in the direction of subvector A can be given as the vector A itself divided by the magnitude of that vector. So similarly, here the unit vector in the direction of this A minus B can be given as this vector A minus B divided by the magnitude of this vector A minus B. So for that, first we need to find the magnitude of this vector A minus B. So it can be given as square root of ax square, that is minus 1 whole square, plus ay square, that is minus 1 whole square, plus az square, that is equal to 5 whole square. And if we calculate the value, then it will come out as root 27. That means here, the unit vector in the direction of the a minus b is equal to 1 by root 27 times this minus ax minus ay plus 5az. And in this way, we got our unit vector in the direction of the a minus b. So similarly, now let us see the second part of the question. So in the second part, we've been asked to find the unit vector in the direction of the line that is extending from the origin towards the midpoint of the line that is joining the point A and the B. So first of all, let us understand what it means and what we have been asked to find in the question. So here, there are 2 points A and B in the Cartesian form. Let's say this is point A and this is point B. So first of all, let us draw a line that is joining the point A and the B. And now let's say the midpoint of this line is equal to M. So here, we've been asked to find the unit vector that is starting from the origin and joining this point M. So basically, here we've been asked to find the unit vector in the direction of this vector M. And for that, first of all, we need to find this vector Rm. And of course, to find that, first let us find this point M. So here, since M is the midpoint, so we can say that this M is equal to A plus the half of the distance between the point A and the B. Let's say the distance between the 2 points is equal to small d. That means here, this M is equal to A plus d divided by 2. And we know that this distance d can be given as A plus this b minus a divided by 2. So in this way, we can find this distance d. So based on this, if we see the x component of this point M, then that is equal to this ax plus this bx minus ax divided by 2. So that is equal to 1 plus this 2 minus 1 divided by 2, and that is equal to 1.5. That means here this mx is equal to 1.5. Similarly, this my is equal to this ay plus by minus ay divided by 2. So here this ay is equal to 2 and this by minus ay is equal to 3 minus 2 divided by 2. That means here this my is equal to 2.5. So in this way, we also got the second coordinate of this point M, that is equal to 2.5. And likewise, this mz is equal to this az plus bz minus az divided by 2. So here, the z component of this a vector is equal to 3. That means here, this mz is equal to 3 plus minus 2 minus 3 divided by 2. That means here, this minus 2 minus 3 is equal to minus 5 and minus 5 divided by 2 is equal to minus 2.5. That means this mz is equal to 3 minus 2.5, that is equal to 0.5. So in this way, we got all the 3 coordinates of this M point. And from this, we can say that this vector M is equal to 1.5 ax plus 2.5 ay plus 0.5 az. And now, we need to find the unit vector in this direction. So let us find that. So here, the unit vector in the direction of the M can be given as this vector M divided by the magnitude of this vector M. So that is equal to 1.5 ax plus 2.5 ay plus 0.5 az divided by the square root of this mx square plus my square plus mz square. So in this case, that is equal to 1.5 whole square plus 2.5 whole square plus zero point 0.5 whole square. So if we just see the denominator, then it will come out as 2.95. So we can say that the unit vector in the direction of the m is equal to 1 divided by 2.95 times this 1.5 ax plus 2.5 ay plus 0.5 az. And if you want, then you can also further simplify it. Then it will come out as 0.5 ax plus 0.847 ay plus 0.169 az. So in this way, we got the unit vector in the direction of the m. So far, we have seen the examples based on the position vector, distance vector and the unit vector. So now, let us see the next example based on the vector field. So in this question, we have been given the two vector fields g and the h. So here, first we have been asked to find the magnitude of this vector field g and the h at this point P. And then after, we have been asked to find the unit vector at the point P. So first of all, let us find the magnitude of this vector field g and the h. So to find that, first of all, let us find the respective vectors for this vector field g and the h at this point P. So let's say for this vector field g, the vector at the point P is equal to gp. And it can be found by putting the value of x, y and z as 1, minus 2 and the 3 respectively. That means here, this vector gp is equal to 1 whole square ax minus 2 times ay plus 2 times 3 times az. So that is equal to ax plus 2ay plus 6az. So for this vector, if we see its magnitude, then that is equal to square root of 1 whole square plus 2 whole square plus 6 whole square. And that is equal to square root of 41. That is roughly equal to 6.4. So similarly, for this vector field h, let us find the vector at the point P and let's call it as HP. And to find that, once again in this expression, let us put the value of x, y and z as 1, minus 2 and the 3. That means here, this vector HP is equal to minus 2 times 3 times ax plus 3ay minus 1 times 3 times az. That means this HP is equal to minus 6ax plus 3ay minus 3az. And now, if we see its magnitude, then that is equal to square root of minus 6 whole square plus 3 whole square plus minus 3 whole square. So that is equal to square root of 36 plus 9 plus 9, and that is equal to square root of 54. So if we further simplify it, then that is roughly equal to 7.348. So in this way, we found the magnitude of this vector field g and the h at this point P. So similarly, for this vector field g, let us find the unit vector at the point P. So we already know that this vector gp is equal to ax plus 2ay plus 6az. And we also know the magnitude of this gp, that is equal to square root of 41. That means now, the unit vector in the direction of the vector gp is equal to the vector gp divided by the magnitude of this vector gp. So that is equal to ax plus 2ay plus 6az divided by square root of 41. And if we further simplify it, then it will come out as 0.156 times ax plus 0.312 times ay plus 0.937 times az. So in this way, for this vector field g, we also found the unit vector at this point P. So I hope through these examples you understood if we have been given some points in the Cartesian coordinate, then from that, how we can find the position vector, distance vector as well as the unit vectors. And moreover, you also understood that if we have been given some vector field, then how we can find the unit vector at the specific location. So now in the next video, we will learn about the dot product and the cross product. So if you have any question or suggestion, then do let me know here in the comment section below. If you like this video, hit the like button and subscribe the channel for more such videos.